Hey everyone, so this is going to be lesson 1 for the unit 3 trigonometry, so that we're going to talk about similar triangles. So similar triangles have the same shape but are different sizes. So corresponding angles are equal, so all the angles in the shape are equal. It's the sides that are proportional. So example 1, look at the triangles to the right. We're going to write down the proportion statement for these triangles. So we can see that angle A, where the x is, and angle R. This means that since it's the same shape, these are the angles are the exact same. Also, the dot for the angle C and the dot for angle T, these angles are exactly the same. So that means that if all these angles in the two triangles are the same, they're similar triangles. What's going to be off is the distance. The side lengths are going to be proportional to each other. So let's look at the big triangle first. So if I'm looking at side AB, that is the same side as RS from the little triangle. Okay, and that proportion would be this equal to the side AC on the big triangle. So from here to here, that is proportional to RT, R to T here. And then lastly, this is equal to the proportion of BC, so from B to C on the big triangle, and the same side on the smaller triangle is ST. So it will have the same proportions between all the different sides. So we're going to substitute the given values we have into this statement. So I know that AB, so from A to B, the length is 12. So I'm going to plug that in for AB. And I know from RS, my length is 7. So I'm going to plug that in for RS. Then for AC, A to C, there's an X value. This is the value that we want to find out. So I'm just going to put X into there. And then for RT, from R to T, the side length is 3. And then for BC, B to C and S to T, there's nothing there. So we're just going to leave BC and ST. So pretty much these two lengths don't matter here because we're not going to be using it for solving for X. Okay, so circle the two fractions you would use to solve for X. So we'll be using the 12 over 7 and the X over 3. The two fractions that you'll be using, one of them has to have a number on top and on bottom. The other one has to have only one number and then one variable. So I have X and 3. Okay, so we're going to solve by cross multiplying the circled fractions. So I just took those two circled fractions and I wrote it on this page. So we've got 12 over 7 equals X over 3. So the first thing you do is you cross multiply. So that value that's underneath X, we cross it over to the top. Those two multiply together. Then we divide by the other value that we haven't used yet. So that's 7 down there. So 12 times 3 divided by 7, we've got 5.14. That means that length AC, where my X is, the length of it is 5.14. Let's look at another example too. So triangle MAN and triangle BOY, they are similar triangles. So we're going to find the length of OY here. So N, since we have an X here, this angle N is the same as angle Y down here. This dot for M and this dot for B should be up a bit more. That means these two are the same angles. That leaves A and O also the same angles. So for the big triangle and the little triangle, if I'm looking at MA, So MA. That's the exact same side as B and O based off of the angles. Okay, that proportion is going to be equal to AN. So when I'm going A to N, so green to red, that's the same as going from O to Y. And that proportion is going to be the same as N to M, so red to blue, the same as Y to B. Okay, so let's plug what we have in already. So I know my MA, so my M blue to green is 27. So I can plug 27 into there. Then we're going to look at B, so this blue to green, the length is 17, so I can plug that in for BO. This is equal to AN, so A to N equals 19, so I can put 19 into there. And then OY is the length we're looking for, so it says find the length of OY. So we're just going to put an X in for there. We're going to put a variable. And then NM and YB, we're not worrying about it here, so we can just leave it as NM and YB because we already have the two fractions that we're going to be using to solve for X. So we're using these two fractions, so we're going to cross it, multiply. So whatever side that the X is on, the one that's either above it or below it, we're going to take that and we're going to cross it over and we're going to multiply it with what's on the other side. And then I divide it by the 27 at the, that's at the top. So I do 19 times 17, divide that by 27. That means the length of OY is going to be equal to 11.96, or we can round that up to 12. Okay, and then example 3. To calculate the height of a house, a student uses the height of a pole and the lengths of the shadows cast by the pole in the house. How tall is the house? So the first thing I'm going to do, we're looking at how tall the house is. So we're going to put a variable there. So we're going to put variable X. Okay, that length is going to be, that side is the similar side to the 3.5, so the height of the pole. Okay, so we've got X over 3.5. So we're doing the big triangle first, then we're going to do the little triangle at the bottom. This is equal to, and then this side here, the 4, is similar to this side here, the 1.5. So I'm going to go 4 meters over 1.5. We cross it so that, again, the number that's on the side of the X, we cross it over, we multiply it, and we divide by that other number that we haven't touched yet. So we do 4 times 3.5, and we're going to divide it by 1.5. We get 9.33 meters. This means that the house is 9.33 meters tall.